In this slide, we use common operations like file open and file read to give everyone an example to enhance understanding. When we want to open a file, we first have to check the directory structure to see if this file exists. Since the directory structures does not load all information into memory at once, we may still need to load the missing part from the disk into memory. After we find a desired directory structure, we obtain the corresponding file control block, FCB. This is because there are pointers in the directory that point to the location of this corresponding FCB on the disk. Finally, this FCB has to be loaded into the system-wide open file table in memory. When we want to read/write the file, there should exist two tables in memory at this point. One is the aforementioned system-wide open file table, and the other is the per process open file table. Through the per process open file table, we will know which files this process has opened. Assuming the process has opened 4 files, this table will have 4 entries to record the relevant information. After finding the corresponding file entry, we have a pointer that points to the system-wide open file table to retrieve the FCB inside. With this SCB, we will get more information about the file, including whether we have the permission to access it and in which data blocks the file is actually located on the hard drive. In our previous slide, we have recognized that maintaining the directory structure is very important. It is not feasible to load all directories into memory, since the directory in a computer system is not only large, but also quite complex. Even a file name, how to quickly locate the target within this structure, is a point of consideration in design. We can use pointers to link the file name with its corresponding data blocks. This method is a form of linear list approach. It is simpler to implement, but performs poorly in terms of efficiency, such as when adding or removing files. When we want to add or remove a file, searching target in such a directory structure takes linear time. We can speed out the search time by sorting the file name. To maintain an ordered list of file names, we can use a linked list or B+tree to implement alphabetical order. Hash tables are another method, which store the linear list using a hash data structure. When a file name is input into a hash function, it outputs a value. With this value, we can go directly to the corresponding bucket to find the data, thus reducing directory search time. However, hash tables have what is called a collation problem, which occurs when two files' names map to the same position. Once a collision occurs, we link them using a linked list. Because of the nature of the hash function, such as the bucket size being predetermined, it is more advantageous for entries of a fixed size and less supportive of dynamic size changes.